Well, hello, wonderful physics students. I wanted to be here with you today to go over another practice problem with CVPM, our constant velocity particle model questions, because I think we could use one more practice problem. So here we go. So let's say we have Fred and Pam, and they love each other, and they're running across a field to each other. Let's say Fred is running at 7 meters per second, and Pam is a little slower at 3 meters per second. And there is 105 meters between them. Okay, so we want to find where they will meet. Will they meet right in the middle, or closer to Fred, or closer to Pam? You're right, they'll meet closer to Pam because Pam is running slower. So this is where true love will happen. Aww. All right, and we just want to find out where is this? Where will they meet? So we would like this distance x right there. How far does Pam have to run to meet Fred? Okay, so the only equation that we have so far in our arsenal is velocity is change in x over change in time. All right, so let's look at this a little bit. So they have to run, they don't have the same velocities. Fred has a velocity of 7 meters per second and Pam has a velocity of 3 meters per second. They do not run the same distances. Obviously, Fred is going to run further than Pam. But they do have the same times. They start at the same time and they finish at the same time. So let's go ahead and solve for change in time on one side of the equation and have everything else on the other side of the equation. Okay, so let's do this. So since change in time is in the denominator, let's multiply both sides of the equation by change in time. So we have velocity times the change in time equals change in x. And then we divide both sides by velocity, get change in time by itself. Change in time is equal to change in x divided by velocity. All right, so let's come over here. The time that it takes Fred to meet Pam is equal to the time that it takes Pam to meet Fred. And that's going to equal change in x over v. So change in x, how far Fred ran, over the velocity of Fred equals change in x, how far Pam ran, over the velocity of Pam. So let's plug in things that we know. Pam, we're calling her x. She ran x, and her velocity is 3 meters per second. Fred, well, let's see here. Fred runs this much. So he runs the whole thing, 105 minus what Pam ran. So he runs 105 minus x. Over Fred's velocity, which is 7. So we could cross multiply. So now we have 3 times 105 minus x equals 7x. And then we have to distribute. So 315 minus 3x equals 7x. Add 3x to both sides. So 315 equals 11x. Divide both sides by 11, which I did earlier, and it's 28.63 meters is equal to x. Don't forget your units. No naked numbers. Okay, that's a point. Okay, so that makes sense. This is 28.63 meters, and this is the rest. So this is bigger than Pam's. Very good. Okay, now if we want to, we can also do this graphically. So if we were to have some graph paper and be very, very careful with things, and get a different color pen here. We know that this is always time and that this is position. And Fred, let's say Fred's at the origin and he has a pretty steep slope like this. But we'll do Pam in a different color. Do Pam in red. So Pam is at 105 meters away from Fred, who starts at the origin. She's going to run slower towards Fred, so her slope is not as steep as Fred's, like so. And this is where they meet. Oh, true love. Alright, if we look over here, this should be 28.6 meters. So, let's see. 105 minus 28.663, 76.37. So this would be 76.37. That's how far Fred ran. If we want to find the time, we just have to plug this back into one of the equations. So we could say 28.63, I'll plug it into this side, divided by 3, 9.54 seconds. So this is 9.54 seconds. Alright, I hope this helps. I hope you have a wonderful day, and I will see you when I get back. Bye-bye.